Today we're going to be talking about power of a power. So we're going to start with an investigation. And our question is, what happens when you have a power on a power? So what happens when you have one base with two or more exponents on it? So we're going to try two examples, take a look at what we get, and then see if we can come up with a shortcut. So I have 3 to the power of 5 to the power of 2. So I'm going to think about what that means. 3 to the power of 5 to the power of 2 means I have two 3 to the power of 5s being multiplied together. Now we learned that when you multiply two things together with the same base, you can add their exponents together. So if I have 3 to the 5 times 3 to the 5, that's going to give me 3 to the power of 5 plus 5 if I add those exponents together, which is 3 to the power of 10. We're going to try our second example, which says 3 to the power of 7 to the power of 3. What that means is we are multiplying 3 6 to the power of 7s together. So I have 6 to the power of 7 times 6 to the power of 7 times 6 to the power of 7. Now once again, this is a multiplication question and they all have the same base. So I can simplify it by adding the exponents together. So this is 6 to the 7 plus 7 plus 7. 7 plus 7 plus 7 is 21. So it's the same thing as 6 to the power of 21. So what I would like you to do is take a minute and put on your thinking cap and see, is there a way that we can go from our original questions to our final answer as a power without having to do all of those middle steps? Hopefully you noticed the same thing I did, which is that 5 times 2 is 10 and 7 times 3 is 21. So when you have two powers on the same base, you can simplify it by multiplying those two powers together. So it says when you have an exponent on a power, you leave the base the same, and multiply the exponents. So when you have a power that has an extra exponent on it, you leave the base the same and you multiply your exponents together. So we're going to try 4 examples of that just to see how it goes. So our first one here says simplify using exponent laws. And our example is 2 to the power of 7 to the power of 5. So I have one base with two different exponents on it. So I can simplify that by leaving the base the same, so it's still 2, and then multiplying my exponents. So 7 times 5. Now 7 times 5 is 35. So this is 2 to the power of 35. Do you need to show me the step where you showed that we were going to multiply, or can you just skip right ahead to the answer? The answer is you can just jump straight to 2 to the power of 35, but because this is our note, I showed the extra step. If I take a look at our second example here, I have 3 to the power of 2 to the power of 4 to the power of 5. So I notice that there's only one base and there are 3 exponents. So when I only have one base and multiple exponents, I'm going to multiply them together. So I leave the base the same, that's 3, and then I'm going to multiply 2 times 4 times 5. Now 2 times 4 is 8, and 8 times 5 is 40, so this is going to be 3 to the power of 40. You can also use your calculator if you like. The next two questions are very similar. I have 5 to the power of 3 times 5 to the power of 9 to the 2, and I have 5 to the power of 3 times 5 to the power of 9 all to the power of 2. So the only difference between these two questions is that this one has an extra set of brackets that this one does not have. Otherwise, they have all the same powers, they have all the same exponents. And I want to talk to you about what difference that bracket makes. So if I look at this first one that says 5 to the power of 3 times 5 to the power of 9 squared, whenever you're doing a question that has more than one operation, you should always try to follow order of operations or BEDMAS. So the first thing we should start with is brackets, then exponents, then division and multiplication, and then addition and subtraction, but we will not see addition and subtraction questions. So I notice I have 5 to the power of 3, and then that's being multiplied by 5 to the power of 9 to the power of 2. Now that power of 2 only applies to the 5 to the power of 9. This is the only part that is to the power of 2. So I would start with brackets, and I do have a bracket, but there's nothing to do inside the bracket unless I wanted to work out 5 to the power of 9, but the question says simplify, so I don't want to work it out. I just want to try to use exponent laws. So that brings me to exponents. So all of these have exponents, but I'm talking about an exponent on top of an exponent. So I'm going to leave the 5 to the power of 3 by itself, and then we're going to multiply by whatever 5 to the 9 to the 2 is. So since this is one base with two exponents, I'm going to multiply those together. So I leave the base of 5, and then 9 times 2 is 18. So you'll notice this time I didn't write in that extra step, and if you want to put that in, that's great, but you don't have to. So I simplified the exponent first, and now I'm going to do the multiplication. So we know that when you multiply two things with the same base, you leave the base the same, so it's still 5, and then you add your exponents together. So I could write 3 plus 18, or I could just add 3 and 18. 3 plus 18 is 21. So this equals 5 to the power of 21. So in this instance, that power of 2 was only on the 5 to the power of 9. But in our next example, you'll notice that the power of 2 is outside of this big square set of brackets, which means the power of 2 is actually on everything inside the bracket. So when I start this one, I am going to follow BEDMAS, and I'm going to start with brackets, and I do notice that I have that enormous set of square brackets there. So I'm going to start by doing what's inside those brackets. What's inside those brackets? There's some multiplication. So I know that when we multiply two things with the same base, we leave the base the same, so that's 5, and we add the exponents. So 3 plus 9 is 12. And then that is still inside of a bracket to the power of 2. So I've simplified what was inside the bracket. I still have a bracket just to separate the two exponents, but now I'm going to move on to exponents, and we're going to figure out what having a power of 2 on this is going to do. So 5 to the power of 12 to the power of 2, I have one base with two exponents. I leave the base the same, and then I multiply these exponents together. So 12 times 2 is 24. So even though I had the exact same bases and exponents, just adding that bracket changed the question, and I ended up getting a completely different answer. So you can join me in the next video if you like to learn how to do exponent laws with coefficients.